Next, we will have a discussion on aerosols. Now, before we start, what is an aerosol and how aerosols are going to affect the climate? One very important thing that you need to understand is the fact that the effect that aerosols have on climate is opposite to what you have learned for greenhouse gases. That, if you remember, we discussed the term positive radiation forcing, right? So positive radiative forcing is caused by the greenhouse gases and all these sources which warm the atmosphere or the lower surface of the earth. In case of aerosols, it's opposite in the sense that it has a negative radiation forcing. It has a negative radiation forcing. It means that it would cool the environment. It would cool the surface as well as the lower strata of the atmosphere. So this is what happens with aerosols. But first of all, what is an aerosol? So in very basic terms, aerosols are minute particles or minute particles suspended in the atmosphere. So when these particles are sufficiently large, that is when we start to notice their presence, but they can be very small and there can be many types of aerosols. So briefly we'll discuss what are the types of aerosols. Just understand that these are minute suspended particles in the atmosphere which can have many sources. The sources can be natural, the sources can be man-made. So let's discuss all these sources or the types of aerosols that we have. The very first one that we have are volcanic aerosols. So what do we mean by volcanic aerosols? Volcanic aerosols basically follow an eruption. Large amount of sulfur dioxide, hydrochloric acid, ash, etc. get onto the surface of the earth during a volcano. So for example, hydrochloric acid. In most cases, it condenses with water vapor and is rained out of the volcanic cloud formation. Sulfur dioxide from the cloud is transformed into sulfuric acid. Now this sulfuric acid will quickly condense and produce an aerosol particle which will basically linger on to the atmosphere for a very long period of time. But when I say very long period of time, this very long period is not as long as the effect of carbon dioxide or methane. Please don't confuse there. This long is very, very short as compared to the time periods we discussed for carbon dioxide or methane. But still, what happens is, this is coming or this kind of aerosol is formed from volcanic activities. What happens is, if we talk about the volcanic activities, there in that case, sulfur dioxide would come out, hydrochloric acid will be formed, and this sulfur dioxide, when it comes in contact with water vapor, it finally will lead to the formation of sulfuric acid. And this sulfuric acid will be present in the atmosphere as very, very tiny particles, and that's why this will be called as an aerosol. Similar would be the case with other gases that are being formed. And apart from that, there can be another kind of aerosol, and that basically is coming from desert dust. So this becomes the second type of aerosol that may have very significant effect in the climate of a desert, because the dust that is composed of various kinds of things, for example, there can be many kinds of minerals, these kind of particles will absorb the sunlight and also scatter it. So the dust, the desert dust would become another kind of aerosol for you, and this would absorb and scatter sunlight. So in that manner also, they would decrease the intensity of sunlight that reaches the surface of the earth. So this is the second kind of aerosol. Another kind of aerosol, before we discuss the human-made aerosols, can be sea salt aerosol. This basically will be formed from the oceans, or mainly the waves. From the waves, very tiny particles of water vapor as well as the water vapor containing salt would get suspended in the air, and once it gets suspended in the air, this will form the kind of aerosol that we call as sea salt aerosol. So this becomes the third kind of natural aerosol. So this is natural, these two are natural, right? Now apart from that, the next kind of aerosol that we have is a human-made aerosol. Now a large part of this aerosol comes either from burning of coal and fuel, or coal and petroleum, and burning of forests as well. The concentration of human-made aerosol, especially the one which is called as sulfate aerosol. This is the one which has been growing immensely since the start of the Industrial Revolution. And at the current production levels, the human-made sulfate aerosols are thought to overweight naturally produced aerosols or naturally produced sulfate aerosols. So what happens is the sulfate aerosols will absorb no sunlight, but they reflect it. So thereby what they do is they reduce the amount of sunlight that reaches the surface of the earth. So, and again, this sulfate aerosol is supposed to be there in the atmosphere for 3 to 5 years. And since they can be there in the atmosphere for 3 to 5 years, they become much more dangerous as compared to other kinds of aerosols. So when we are discussing human-made aerosols, the first one for us is sulfate. And the main reason why the sulfate aerosols are coming are basically from the chimneys. Basically, this is because of burning of coal and oil, or you can say petroleum. One issue related to sulfate aerosol is that it can remain suspended in the atmosphere for 3 to 5 years, which is much more than any naturally occurring aerosol. Now, another fact about sulfate aerosol is that they can also enter the cloud, and where they can increase the number of cloud droplets by decreasing the size of each droplet. Now, in this what happens is the net effect is to make the clouds reflect more sunlight than they would without the presence of sulfate aerosols. So what they do is they decrease the size of droplets in the cloud. Therefore, it will lead to more reflection of sunlight. So this will be another effect that we can have. So we are talking about the fact that the net effect here will be that the clouds reflect more sunlight than they would if there was no sulfate aerosol present here. Now, one thing to discuss here is that the production of aerosols, they represent a very important anthropogenic radiative forcing. Collectively, the aerosols, what they do is they block a portion of incoming radiation, and this creates a negative forcing. So what they are doing is that they are blocking a part of solar radiation, and by blocking a part of solar radiation, they create a negative radiative forcing, right? So something that we started our discussion with. Now, one more thing which is important is that when you talk about aerosols, they are second just to greenhouse gases if you talk about the relative importance in their impact on the surface temperature or the atmospheric temperature. So the difference here is that the residence period that we discuss for greenhouse gases can be more than a decade. But here in case of an aerosol, it would maximum be 3 to 5 years. So this is one major difference between the two. Now, what happens is they get dispersed. Either they would get dispersed by wind or they would get dispersed by rain. Either of the two would be able to disperse the aerosols. So if we talk about the dispersal, it can either be through rain or precipitation, or second, it can be through wind. In this case, it would be called as wet dispersal, and in case of wind, it would be called as dry dispersal. So start again from wet dispersal, wet deposition, and in case of wind, it would be called as dry deposition. So in these two manners, they can get dispersed, and this dispersal is actually very, very fast as compared to the dispersal of greenhouse gases. Now, just to discuss the dispersal of sulfate aerosol, what has happened is since 1980s, the global emission of sulfur dioxide has decreased. And if we just take an example, in 1980, the total amount of sulfur dioxide emission was 73 million tons per annum or per year, but in 2010 it was approximately 54 million tons. So there has been a decrease in the amount of sulfur dioxide or in the atmosphere, which has reduced the amount of sulfate aerosols in the atmosphere. Now, apart from the sulfate aerosols, we also have nitrate aerosols. Now, nitrate aerosol is not as important as the sulfate aerosol, but it has a potential to become a very significant source of negative forcing. So you have to understand, as it is an aerosol, aerosols have a negative forcing, right? So one major source of nitrate aerosol can be smog, and we have had a separate discussion on smog, so I'm not going to discuss smog here. So this smog basically gets released from the incomplete combustion of the burning of fuel in all these internal combustion engines. Another source for nitrate aerosols can be ammonia, right? Where normally you will see that ammonia is used in the fertilizers or are released by the burning of plants and other organic matter. So if greater amount of atmospheric nitrogen is converted into ammonia and agricultural ammonia emissions continue to increase as projected, the influence of nitrate aerosols on radiative forcing is also expected to grow. But right now, the effect is very negligible as compared to sulfate aerosol. But both sulfate and nitrate aerosols are actually acting primarily by reflecting the incoming radiation, and that's why they are reducing the amount of sunlight that reaches the surface of the earth. Most aerosols, unlike your greenhouse gases, they would impart a cooling rather than a warming influence on the earth, and that's why negative forcing. But there is an exception to this as well, and there you have the carbonaceous aerosols. Now, carbonaceous aerosols, for example, you can take as carbon black or soot. So they basically are produced from where? They are also produced by the burning of fossil fuels. And not only burning of fossil fuels, also from the burning of biofuels. So they tend to absorb rather than reflect the incident radiation. And that's why it has a warming impact on the lower atmosphere rather than having a cooling impact. So because of its absorbing properties, carbon black is also capable of having an additional indirect effect on climate. So just to remember that when we say aerosols, aerosols are not associated with global warming, but they are associated with climate change. Okay, so there is a difference, as we just discussed in the beginning of climate change, that we'll use two terms, climate change and global warming. Here we are saying that aerosols are agents of climate change and not an agent of global warming, except for carbonaceous aerosols, which would have a warming effect. All the other aerosols would have a cooling effect. Correct? So next, if we just have a look at some of the points as we just discussed, aerosols block a portion of incoming solar radiation, and this creates a negative radiative forcing. Aerosols are second only to greenhouse gases in relative importance in their impact. This we discussed. They are readily flushed out of the atmosphere within days, either by rain or snow, which is called as wet deposition, or by settling out of the air, that is dry deposition. This can also be through the action of wind. Then they have the ability to influence climate directly by absorbing or reflecting the incoming radiation, but they can also produce indirect effect on climate by modifying the cloud formation or cloud properties. Apart from that, they can be transported thousands of kilometers from their sources of origin by wind and upper level circulation in the atmosphere. So all these facts about aerosols you should know. Now one more thing to note here is that the warming effect of greenhouse gases are basically expected to take place everywhere, but the cooling effect of the aerosols, they will be somewhat regional in nature. It will be very much near the industrial areas or in the areas where you do not have a movement of wind. For example, the smog situation that we see in North India, that also happens because of the fact that the movement of air does not happen during winter times in these areas. It's not only pollution that is causing the smog, but human activities have greatly increased the amount of aerosols that are there in the atmosphere. And in contrast to the global effects of greenhouse gases, the impact of aerosols is confined primarily to the northern hemisphere only. So what we have seen is most of the industries are located in the northern hemisphere, and that is causing the higher amount of aerosols in northern hemisphere as compared to southern hemisphere. Please remember these small facts because this can be a direct fact for your prelims examination. Now, during the middle of 20th century, there was a substantial increase in the aerosol emission. And this basically what it did is that it impacted the warming that was happening in the northern hemisphere. So especially since you can say in 1940s up to 1970s, this was a time where we saw that there was a negative radiative forcing which was also impacting the effect of global warming. The negative radiative forcing of aerosol basically offsets the warming by approximately 40%. But the relative uncertainty in the aerosol radiative forcing is very high. I mean, the probability is very low of being able to calculate how much it is able to impact in comparison to the greenhouse gases. Now, in addition, the future emissions of aerosols from human activities and the influence of these emissions on future climate change are also not very well known with certainty. But what we can say is that if the concentration of the anthropogenic aerosols continue to decrease, as they have, as we discussed in case of sulfate aerosols also, that a significant offset will be seen in the effect of global warming. So basically the effect of global warming, which would have been partially neutralized by the aerosols, that will be much more visible now as we are decreasing the amount of sulfur dioxide and other gases which cause this negative effect or which are being able to neutralize the effect of global warming. So what we can say is that in the coming years, or you can say in the last few years, we have been able to see much more of global warming than we were able to observe in 1970s or 1980s. So a very related concept here is also global dimming. So what do we mean by global dimming? It is defined as the decrease in the amounts of solar radiation reaching the surface of the earth. And this basically is happening why? Due to the action of aerosols. So various regions observe different levels of global dimming. In southern hemisphere, as we discussed, it has seen very small amounts of global dimming, while northern hemisphere has witnessed more significant reductions up to 4 to 8%. So what we are saying is that the total amount of solar radiation that reaches the surface of the earth, that has decreased by 4 to 8% in the northern hemisphere due to the action of aerosols, and this concept is called as global dimming. So the regions such as parts of Europe, North America has observed partial recovery from dimming, while parts of China and parts of India have experienced increased global dimming. So you can relate it to the increasing in the amount of smog that we see in the northern part of our country. So the causes, if you very simply want to know what are the causes of global dimming, in very simple one word, the answer is aerosols. Aerosols have been found to be the major cause of global dimming. The burning of fossil fuel by industries and the internal combustion engines, they have emitted byproducts such as sulfur dioxide or carbon black, soot. These together, ash also you can include there, these together form the particulate matter. And primarily, that's why these are called as aerosols, and aerosols act as precursor to global dimming in many ways. I mean, if you just have to discuss a few, the particulate matter can enter the atmosphere directly and absorb the solar radiation and reflect the solar radiation back into the space. And that's why a much lesser amount of solar radiation would reach the planet's surface. Apart from that, the water droplets that contain the airborne particles, they form the polluted clouds. And these polluted clouds have heavier and larger number of droplets, although sizes are smaller. And these change properties are sometimes also called as brown or black clouds. So if we have to discuss the effects of global dimming, first of all, you have to know that the effects of global dimming would be devastating, and especially on the environment and the living beings living on the earth. The pollutants causing the global dimming also lead to the problems like acid rain, smog, etc., and respiratory diseases in humans. So that's why it will have a bad effect on human life. Apart from that, due to reflection of solar energy and global dimming, the water in the northern hemisphere has become colder. So what we have seen is water in the northern hemisphere has become cooler, and this has led to slower evaporation and generation of lesser water droplets. So this basically causes the reduction in the amount of rain that reaches certain parts of the globe and resulting in drought and famine situations. Not only this, decrease in sunlight or the solar radiation will negatively impact the process of photosynthesis in plants. So if you have to summarize what kind of problems can be caused by global dimming, you have to understand one, that there will be increase in the respiratory diseases, more acid rain, more smog. Apart from that, there would be severe droughts and it can lead to famine. And finally, there can be decrease in photosynthesis in plants. So you should not think in this manner. What we discussed is can also create confusion in your minds. What we discussed is the fact that aerosols have a cooling effect on the environment. So that does not mean that we should have more of aerosols in the environment, because where are the aerosols coming from? Aerosols are also coming from the fossil fuels or the burning of forests, etc. So now that all these are also human activities, the amount of greenhouse gases that are released or the amount of carbon dioxide and other harmful chemicals that are released because of these processes is much higher than the amount of aerosols that are being released. So since these amounts are higher, aerosols, although as we discussed that they can offset global warming by 40%, but they are not negating the global warming altogether. So aerosols are not a solution. Please don't confuse them. Aerosols are not a solution. And apart from that, you have all these diseases that would happen. It would lead to severe droughts and famine situation. So because of all these reasons also, you can say that yes, although they have a negative radiative forcing, although they have a cooling effect, but it does not mean that they are advantageous for the environment. Please don't confuse that. Now, what has happened, as we discussed, that amount of sulfur dioxide and other aerosols started to decrease in the atmosphere. And because of that, what we have seen is that global dimming is not as big a phenomena as it used to be in 1990s. So the decrease in global dimming has also been named as global brightening. The word given to decrease in global dimming is global brightening. So global brightening has led to us realizing the effect of global warming in a much better manner than we would have if global dimming existed. So please remember that this term, global brightening, sometimes you might come to hear this term here and there. So please understand that this is basically understood as the decrease in global dimming that has been seen due to decrease in the amount of aerosols like sulfur dioxide, etc. in the atmosphere.